Hello my dear friends, welcome back to Math with Amala. In the first video we have completed the introduction part which included natural numbers, whole numbers, integers and rational numbers. Now let's move to the example number 1 from this chapter. Every whole number is a natural number. So in whole number set you can see 0, 1, 2, 3 etc. Natural number set 1, 2, 3. But 0 is not found in natural number set. That means this is a false statement. The counter example you can give with 0. The second statement is every integer is a rational. Q means rational. So we can take the integers 0 plus or minus 1 plus or minus 2 plus or minus 3 etc. and Q as P by Q form. This P and Q are taking the values from integer set. So it can take any values like 0, positives and negatives. So every integer is a P by Q form. If we take a single 1, it is having a denominator 1. Again, if we take 1,000, it is having a denominator 1. So whatever be the number we are taking, it is having a denominator 1. That means if we take an integer or a whole number, its denominator should be there and it is not equal to 0 and that number is of the form P by Q. Hence we can say that this is a true statement. And one more example, if we take 1 minus 1 by 1, this also belongs to Q. The next statement is every rational is an integer. Every Q means it's a rational number. So we have to check whether it is an integer or not. In the rational number set, you have the numbers like P by Q. In the integer set, you have 0, plus or minus 1, plus or minus 2, etc. So let's take P by Q equal to 1 by 2 or 3 by 4 or whatever be the number like minus 1 by 8. But it is visibly very clear that it is not in the integer set. Hence, it is a false statement. So we can say without any doubt that this is a false statement since the numbers in the integer set are not of the form P by Q. So that is not possible. The next example, example number 2, here we have to find 5 rationals in between 1 and 2. 1 and 2 are again rationals. So in order to find some values in between some values, we can use the arithmetic mean method, that is the first number plus second number divided by 2. So let's take R and S as 1 and 2. So R plus S by 2 is the mean which is equal to 1 plus 2 by 2 which is 3 by 2, that is 1 by 1.5. It is clear that between 1 and 2 we are having the number 1.5 or 3 by 2. Now let us take 1 and 3 by 2 again. So you can take the mean like 1 plus 3 by 2 divided by 2. All divided by 2. Also 3 by 2 plus 2 divided by 2. Which is equal to, you can cross multiply and take the denominator towards the denominator 2. So 2 plus 3 by 4. Also 3 plus 4 by 4. You will get 5 by 4 and 7 by 4. So we have got two numbers in between 1 and 2. They are 5 by 4 and 7 by 4. In between these two numbers, you have one more number, that is 3 by 2. Okay, now you have got three numbers, 5 by 4, 3 by 2 and 7 by 4. Let's take some more numbers in between. We are having another one more method in order to do this kind of problem. We will discuss that in the exercise part. 5 by 4 plus 3 by 2 divided by, whole divided by 2. That is the next method. Next procedure that we have to do. 5 by 4 plus 3 by 2 whole divided by 2. Also 3 by 2 plus 7 by 4 divided by 2. Cross multiply. 5 into 2 10 plus 4 into 3 12 divided by 4 into 2 8. And along with that you have to multiply that 2. So 8 into 2. Then 3 into 4 12 plus 14 divided by of 8 into 2. So you can see that the denominators are same here. So 22 divided by 16. Also 26 divided by 16. Here the second method I will give you a hint like 22 by 16 and 26 by 16. It is visible that there are some numbers in between these 22 and 26 with the denominator 16. So the next numbers are 23 by 16, 24 by 16 up to 25 by 16 you are having in between. So let's convert this 22 by 16 into its smaller form, 11 by 8 and 26 by 16 into its smaller form. Here we are having the 5 rational numbers in between 1 and 2, 5 by 4, 3 by 2, 7 by 4, 11 by 8 and 13 by 8. Thank you all for watching the video. Please stay tuned for exercise 1.1.